Hi, this is Shailaja. Today we're going to talk about how to perform text generation. First we're going to import all the libraries that we want to perform the task. After importing the libraries, I'm importing the text which is in my GitHub. Here, so we can see there's a lot of text here. So using this text, we are going to perform the task. I'm just loading the text. After downloading it, I'm reading the data from the downloaded file. After reading, I'm just printing to make sure whether it's loaded. After that, I'm printing the unique characters. So there are 99 unique characters. Next, as the model doesn't understand the text format, I'm just gonna create a mapping for characters to numbers. So for every character, we're gonna map a numerical number. So after mapping, I'm just gonna print the output how it looks after mapping a character to a number. So it's just like a key value pair. Next, after converting into a numerical representation, we're gonna do divide the characters into sequences. So I'm just taking the sequence length as 100. So after dividing it, we are gonna create a training examples and targets, and we are going to perform the text generation for understanding what is the target and what is the training. We need to create that data set. So for creating it, for example, sequence length is 4 and our text is hello, the input sequence would be HELL and the target will be ELLO. But for example, if the sequence length is 4, but here we have given the sequence length as 100, it will act accordingly. So after that, the batch method, the sequences will convert individual characters to sequences based on the sequences we have given. So next what we're gonna do is we're gonna create batches. So we're gonna create batches for the data to be modeled. We will be using data tf.data to split the text into manageable sequences, but before feeding this data into the model, we need to shuffle the data and pack it into batches. That is why we are doing we are performing batching. So here we are doing shuffling. Here we are just giving what is the batch size and what is the buffer size. After that, we're going to just shuffling it so that our model gets trained on various data set. After that, we're gonna do now start model building. So using that sequential model from Keras, we're gonna perform this task using sequential model, and we are gonna use 3 layers for our modeling. First is embedding, GRU, and the dense. So embedding, what does it do is it's just a training lookup table that will map the numbers of each character to a vector with embedding underscore dimension using this. And after the GRU layer, it is a type of RNN with size units. So as we have given previously, you can see we have given RNN units 1024. So it will use those units. Here we can use a LSTM layer also. Next layer is dense layer, the output layer with the vocab size is output. So after layering and we've just defined what is going to be our model. After doing this, we are just gonna build that model by calling this build model method. So after modeling, I'm just printing it what we've performed. It can we have just given the sequence length as 100, but it can run on any length. It's just we can give any length here. To get actual predictions from the model, we need to sample from the output distribution. So this distribution is defined by the length over the character vocabulary. It is important to sample from this distribution, as taking the argmax of the distribution can easily get the model stuck in a loop. So that is why we need to perform this distribution. So we are performing it by using this random categorical. So this prediction, after the means we will predict the next character or next index. Next, what we're going to do is we are just predicting the next character index, and from the text we are giving a loss method. So at this point what we are doing is we are just training the model. At this point the problem can be treated as a standard classification problem. Given the previous RNN state and the input this time step, predict the class of the next character. It is what is going to do. So we are going to attach an optimizer too and a loss function using this sparse categorical cross entropy. Loss function works in this case because it is applied across the last dimension of the predictions. Because our model returns logits, we need to set logits flag too. So we have set this as true. Next, so we are compiling it after training. After training, we are just compiling it using the optimizer atom. Next, we are going to configure checkpoints using this Keras callback model checkpoint to ensure the checkpoints are saved during training. So we've given after training, after defining our model, and we are just gonna fit the model. So we are executing it. So since the epochs are 10, it will run 10 times, and the loss, as we can see how much loss is happening. Next, finally after our model building, we're gonna do text generation. So we're gonna restore the last checkpoint to keep this prediction step simple. We'll use a batch size as 1. Because of the way RNN state is passed from timestamp to timestep, the model only accepts a fixed batch size once built. To run the model with a different batch size, we need to rebuild the model and restore the weights from the checkpoint. So we are generating text. We are converting our start string to numbers. That is, we are performing vectorization here. Next, we have given temperature and also batch size is 1 here. So as I've said, we cannot change the batch size, so we are resetting the states here using this and running our model again. So what it exactly does is it starts by choosing a start string while text generation, and initialize the RNN state and setting the number characters to generate. So we are setting this characters to generate. You get the predict distribution of the next character using RNN state. Then use a categorical distribution. We're going to use a categorical distribution. So we are just printing by calling this generate text method. So start string we have given as Romeo. So it is just giving what is the blob master, what exactly is the next. So yeah, this is what the output we've got when we have given Romeo as input. So yeah, thank you.